Have you ever wondered how a moving coil microphone works? It's a marvel rooted in the principles of electromagnetic induction. This ingenious technology turns your favorite songs, the dialogue in films, even the sound of your own voice into electrical signals. It's the magic behind speakers, headphones, and a plethora of musical instruments. But the question remains, how does this marvelous piece of technology work? Stay tuned to find out. To understand how a moving coil microphone works, we first need to grasp the concept of electromagnetic induction. This principle, discovered by Michael Faraday, is the process by which an electrical current is generated within a conductor by a changing magnetic field. Imagine a coil of wire, like a slinky, moving back and forth within a magnetic field. This movement creates a change in the magnetic field surrounding the coil, and as Faraday discovered, generates an electrical current within it. This is the essence of electromagnetic induction. Now let's consider the moving coil microphone. When you speak into it, your voice generates sound waves that cause the coil inside the microphone to vibrate within its magnetic field. The frequency and amplitude of these sound waves dictate the movement of the coil. A high-pitched voice, for example, will cause the coil to vibrate at a high frequency, resulting in a rapid change in the magnetic field and therefore an induced current that varies at a high frequency. Similarly, a loud voice will cause the coil to move more vigorously, inducing a current with a larger amplitude. This induced current, which mimics the frequency and amplitude of the original sound waves, can then be amplified and output as sound from a loudspeaker. It's through this process that a moving coil microphone converts sound into an electrical signal. Now that we've got our electrical signal, what happens next? Well, we're not quite finished yet. This electrical signal, or varying current, that we've generated doesn't just sit around. It gets transferred to a loudspeaker. Now the loudspeaker plays a crucial role in our sound journey. It uses something called the motor effect to generate sound. Think of the motor effect as the loudspeaker's engine. It takes our electrical signal and converts it back into sound waves. This is the same sound that started from the speaker's voice and was converted into an electrical signal by our moving coil microphone. But how exactly does the loudspeaker do this? Well, that's a story for another video. We'll dive into the fascinating world of loudspeakers and uncover the science behind how they convert electrical signals back into sound. And just like that, the sound from a speaker's voice is transformed into an electrical signal and back into sound again. In just a few short minutes, we've discovered the magic behind moving coil microphones. We've explored the principle of electromagnetic induction, the conversion of sound into electric signals, and the reproduction of these signals as sound in a loudspeaker. Isn't science fascinating? If you enjoyed this video, don't forget to like and subscribe for more interesting content. See you next time.